Okay, so let's graph the functions. Let's graph these rational functions on number 35. So on number 35, part A, I already found out that there is a vertical asymptotes at x equals 2 and x equals -2, and then horizontal asymptotes at y equals 0. So let's put those in first. So at y equals 2 and -2, there's these. I'm not going to put a solid line in. They're supposed to be dotted lines. Okay, so there's my vertical asymptotes. Then I have a horizontal asymptote at y equals 0. Okay, now I have to draw the graph in. So you've got a couple different ways of doing this. You can put your graphing calculator, put it in a graphing calculator if you want to find out where the other pieces of it, where the pieces of the graph go, or you can just plot points if you want. You know, I don't know which way you would really care to do it. I'm just going to put in the graphing calculator, and I'm going to say 3 divided by parentheses x squared minus 4. Make sure that all the bottom is in parentheses. I don't have to worry about the top being in parentheses because it's just one term. Okay, so I'm gonna go to the table because that graph didn't look too awful much. So, what kind of values do I get? Like -3. What value would I get if I plugged in -3? Where would I plot that point? It would be at 0.6. It's kind of hard to see. 0.6, and at -4, it's 0.25. But I don't really too much care about what the value is. I just know that's positive. Okay, so this graph is going to go forever above. Now I know there's no x-intercepts because to find the x-intercept, you would set the top equal to 0, and the top is 3. There's no way to get 0 on the top, so there's no x-intercepts here. All right, so what happens in between? What happens, say, at 0? What are my values here at 0 from -2 to 2? Well, -2 to 2, I get negative values. So the graph must be underneath here. And if I go back to the graph, I can see it's underneath, right? So it's underneath. I'm not too much worried about where's that y-intercept at? At 0, it's 0.75. So yeah, it's pretty close. And then what about over here? Well, if I go to the graph, it looks like it's up here in this corner. If I go to my table, I can verify that by looking at my points at 3, 4, and 5. See how those are going to be positive values. So it is a positive value. So there'd be my graph for part A. For part A. Let's look at part B. I'm going to work for part B here. Part B says that I have vertical asymptotes at 3, -3. So we'll put those in. 1, 2, 3. 1, 2, 3. I have a horizontal asymptote at y equals 0. All right, now I need to fill in the graph. Is the graph up here? Is it down here? Is it a U shape? Is it a S? Does it come in this way? Is it down here at the bottom, at the top? All right, so I'm just going to, I mean, you can plot points if you want. I'm just going to look at the graph, graphing calculator, or look at the table, because I'm assuming that's probably the way you would do it. I'm going to put 2x on top. There's just one term, but I'm going to put that in parentheses so I don't screw stuff up. All right, notice this. So there is an x-intercept on this one, and the idea is set the top equal to 0. It'll tell you that what your x-intercepts are. So if I set the top equal to 0, I have an x-intercept at 0, which is right here. So it looks to me like the graph is coming in like this. It swoops down like so, and then it is on top again. Okay, that's part B. Part C. Part C says I have vertical asymptotes at 2 and -2, and an oblique asymptote y equals 6x. So let's put in 2 and -2. Right, y equals 6x, so that's going to be if I graph y equals 6x, it's 6x plus 0, right? So the y-intercept is at 0. My slope would be up 6 and over 1. So here's where I start: 1, 2, 3, 4, 5, 6, and over 1. And then I need to get a ruler. Let's get this paper here. Okay, so I've got this graph like that. And if I go back to my graphing calculator and part C, also I want to look here. I would have an x-intercept at 0. Plug a 0 on the top, you get a 0. If I set that equal to top equals 0, I get an answer of 0. No, I wouldn't. Yes, I would. Yeah. 6x cubed equals 0. You divide by 6. You still get 0. And then you take a cube root, and you still get 0. Okay. I have an x-intercept at 0. So, for y equals, type this bad boy in, 6x to the third divided by x squared minus 4. Graph. So, what does that tell us? Little nothing. Let me type this other dude in here. Alright, I'm using Desmos is what I'm using here. And I want to type in y equals parentheses, what was this? 6x cubed, 6x to the third. Close it up, divide by, oh, it already puts it in there like that, cool. So x squared minus 4. Okay. So if I look at it, now look at here. There was a middle part that comes down through here, but then there's also a part that comes in up here. It happens way down here at 30, negative 30 and positive 30, but there is a second part to this graph, If you just have the normal window, you're just going to see this much. But you have to zoom out. There should be more parts to fill in. Okay. But that doesn't really, I really don't have, I really didn't graph it correctly because, well, yeah, I don't have my y-axis really filled in here. So I do have my x-axis is 1, 2, 1, 2, but then my y-axis is counting off by like 10s or 5s or something like that. So that's what the graph of that should look like. And part D. Man, this is so much fun. I would highly suggest not doing this whole thing in one sitting. That's what I've been doing all day today. And I've just gotten to this question. So pace yourself on this exam, final exam review. Man, it's so much fun. Anyways, part D says that I have a vertical asymptote x equals 4. 1, 2, 3, 4. And then I have a horizontal asymptote of y equals -1. And since there's just two pieces to this, what would the x-intercept be? This will tell me a lot. If I take the top, set it equal to 0, 6 is the x-intercept. 4, 5, 6, looky there. So I know the graph has to come through here. And I bet you that the other part's down at the bottom. So if I plug a 3, what would happen if I plug a 3 in? If I plug a 3 into this, 3 minus 6 would be -3. And -3 plus 4 would be a 1. That'd be -3. So 1, 2, 3. So the bottom part comes in like so. Cool. And there's your graph of everything.